Okay, membrane potential. So, how's the membrane potential generated? The membrane potential depends on the opening of potassium channels. Now, these channels are permanently open. They have no gate. They're called leak channels because they're permanently leaking potassium out of the cell. Now, that leakage causes an outflow of positive charge from the inside because potassium is positively charged, which leaves back a negative charge. So, relative to the outside, the inside is always negative, and that causes the resting membrane potential. It's usually around negative 70 millivolts or so. Now that leaves the question, how does the potassium actually get into the cell? Now for that we have the sodium potassium pump. The sodium potassium pump pumps out sodium because we don't like sodium in our cells, and it also pumps in potassium at the same time. It actually pumps out 3 sodium and pumps into potassium at the same time, if you want to know the details. But the point is here, it pumps out the sodium and it pumps in the potassium, and that potassium then can leak out through the leak channels, so that makes the membrane semi-permeable. Semi-permeable because it only leaks the potassium. Sodium cannot leak in, so it's sodium tight. And then again, the potassium leaks out, which means you're leaving behind negative charge on the inside, and that constitutes the resting membrane potential of around negative 70 millivolts. It is not very negative. It could have been more negative because of the potassium flow. The equilibrium potential for potassium, that's where the membrane wants to go, is around negative 90. However, there are other small leak currents that go through the membrane, including sodium. It's very small though, meaning it doesn't contribute much to the membrane potential, but it is enough to get you away from the equilibrium potential for potassium, and it brings you to negative 70 or so instead of like negative 90 from the equilibrium potential for potassium. Look, there's the lab.